Okay, volume of ice cream, is that what you're looking at? Okay, nice. Okay, volume. Okay, volume of a scoop of ice cream. The volume of a spherical scoop of ice cream with radius r is given by v equals, find the rate of change of the volume. So we want to take the derivative of this. Okay. So v equals 4/3 pi r cubed. Okay, 4/3 pi r cubed. And I want to take the derivative with respect to r. Yes. Okay, so we're going to take the derivative with respect to r. So that's going to be 4/3 pi times 3r squared, because the 4/3 is just a constant. Well, the 3's cancel. This is v prime, what I would call v prime. And so this equals 4 pi r squared. Okay. So v prime, which is the rate of change, that's delta v over delta r, is the rate of change. It's the instantaneous rate of change. Now, unless they tell you that it's average rate of change, you must assume that it's instantaneous. Okay. Okay, so delta v over delta r, instantaneous rate of change, which we call dv over dr. Okay, so in our case, the limit as delta r is going to 0. So dv dr is equal to 4 pi r squared. Okay. It says, what is the volume when the radius is 0.5? Okay, the volume is equal to 4/3 pi times 0.5 cubed, which comes out to be something. Okay. This is going to be pi over 6, because this 0.5, so pi over 6, I don't know what that is approximately, but you can write it as pi over 6 inches cubed, which is approximately, plug this in my calculator real quick. Pi divided by 6 is about 0.524. 0.524 cubic inches. Okay. Okay, find the rate of change when r is equal to 0.5. So that's going to be my v prime. That's 4 pi r squared. And that equals, okay, 4 pi times 0.5 squared. This is going to equal, if you used fractions, this would equal pi times, because 0.5 times 0.5 is 2.5, or 0.25 times 4 is
1.
Is 1, exactly.
Okay. It would be 3.14.
Yeah, exactly. So it would be 3.14, 2 maybe. I don't know how many decimal places you want to go out, but yeah, so 3.14, and that's square inches, okay, because it's 0.5 inches times 0.5 inches. So that's the rate of change. So that's a rate of change. That's the how fast the volume is changing with respect to the radius. Okay. So it's changing 3.14 inches cubed. If you want to think of this as inches cubed, you can. Inches cubed per 1 inch. you could think of it like that too, that as the radius increases 1 inch, you're increasing 3.14 cubic inches of volume. Okay, so that's another way to think about it. But the inches will cancel out and you'll get inches squared there.
Professor, for number B, can we leave it as a decimal or would have to keep it as a fraction?
Yeah, you can leave it as a decimal, that's fine.
Okay.
Okay, others that you'd like to cover?
Can you do 36B, the next question?
Yeah, I'll do both of them. Okay, so because they kind of lead into each other. Okay, so
can I please see back what you were doing very fast?
there you go. Okay, so 36. Okay, the revenue is 30x. The cost is x 2/3 plus 400, where x is the number of items produced. Find the average revenue, the average cost, and the average profit. Okay, so the average revenue, okay, the average revenue is going to be equal to 30x over x, which is just 30. Okay, that's the average revenue. Okay, the average cost function, okay, is going to be equal to x to the 2/3 plus 400 all over x, okay, which is going to be equal to x to the negative 1/3, because 2/3 minus 1 is 1/3. I just kind of break this up. Plus 400 over x. Okay. Is it plus or is it minus? Oh, it's plus. Okay. Nice, nice, nice. Okay, and so what would the average profit function be? Well, the average profit function would just be the average revenue minus the average cost. So this is 30 minus x to the negative 1/3 plus 400 over x. So that's the average profit, which we could say is then equal to, if we distribute the negative sign, we go 30 minus x to the negative 1/3 minus 400 over x. Okay, so that's the average profit. So now it says the rate at which, find the rate at which the average cost is changing when 12 items are produced. So we just want the average cost, the change in average cost here. So we want, let's look at the average cost function, which is x to the negative 1/3 plus, I'm going to write this as 400x to the negative first, because we're going to have to take a derivative here, because we want to do the average, the rate of change, the rate at which the average cost is changing, the rate of change, again, that we're assuming instantaneous rate of change, okay, especially when we're just given one data point, which is the 12. So A prime of C, the rate at which the average cost is changing, is going to be equal to negative 1/3 x to the negative 4/3 plus 400 times negative 1 times x to the negative 2. Okay. Okay, so I'm not going to bother simplifying that because it doesn't ask me for the derivative. It asks me for the derivative evaluated at 12. So I'm just going to plug in negative 1/3 times 12 to the negative 4/3 plus 400. I'm going to actually simplify that a tiny bit. That's negative 400. Negative 400 times x to the negative, or times 12 to the negative 2. Okay, and I could plug that directly into my calculator if I wanted to. Okay, and I could get an answer, so let's do that. Okay, so I have negative 1/3. Okay, times 12 raised to the negative 4/3. So I'm going to put parentheses here. Negative, oops. Back. Can I go back? Yeah, here we go. Negative 1/3, negative 4/3, negative 4 negative divided by 3. Okay. Close the parentheses. Boom. That's good. Okay. Minus. I'll just hit an equal sign on that one, so I'm all caught up. And then minus 400 times 12 to the negative 2. I can actually do that kind of in my head. That's dividing by 12 times 12, which is 144. So, okay, and I get negative 2.79 on this one. Negative 2.79. Okay, so the average, the average cost is changing at negative $2.79. Okay, per unit, when 12 units have been produced. Okay, when 12 items have been produced, this is changing. So the cost is going down. Okay, the cost is going down. Okay, others that you'd like to see done?
Professor, could we do 21 and 22 in chapter 1?
And Darlene said 40 in chapter 1. Let's do that. 22 and 21. Okay, finally, 21 and 22. And 41. Okay, let me write that down here. 40, 41. Okay, so okay, so would you want 20 and 21 or 21 and 22? I forget now.
Oh, 21 and 22.
21 and 22. Okay, sounds good. Okay, find the equation of the tangent line to the graph. Okay, at the point. So we have to find a derivative, right? To find the tangent line, we want to find the derivative at that value. That will get me the slope of the tangent line, right? So no matter what we have here, if we want the slope of the tangent line, the slope of the tangent line is the derivative at that point, at that x value. Okay. So, well, y prime is equal to 4 plus negative 6 times the derivative of 1 over x. What's the derivative of 1 over x?
Negative 1 over x squared.
Exactly. Thank you. Yes. That's one of the ones that I told you to memorize. Okay. Negative 1 over x squared. So those negatives are going to cancel. But now we need to just evaluate this, well, at 3, right? So let's just plug in for 3 here. 4 plus, those negatives are going to cancel out, and that's going to be 6 over 9. So this is 4 and 6/9. Okay. Well, that's just 4 and 2/3. I'm going to write this as a mixed number or an improper fraction. So if this is 2/3 and 3 times 2, this is 14/3. That's going to be my m. Does that make sense? So what's the equation of my line? Well, I just use point slope form. Y minus 10 is equal to 14/3 times x minus 3. And I can leave it like that. I don't have to simplify. It just ask me for the equation of a line. That doesn't ask me for the equation of a line in slope-intercept form. So that's good enough on that. If you really wanted to go the extra mile and solve it for slope-intercept form, you could. It's just y equals 14/3 x minus 4. It's all good. Okay, 22, find the points on the graph at which the tangent line is horizontal. Well, what's the slope of a horizontal line?
0.
0. Thank you, Giselle. Okay, it is 0. Okay. My stuff is way too high here. There we go. There we go. Okay, so the slope is 0. So we want to know, where is y prime equal to 0? Well, we got to find out, well, what's y prime to begin with, right? When is y, for what value of x? You know, we can think of this as f of x, right, equals x cubed minus 2x squared. But for what value of x, I'm asking myself, well, what value of x is the derivative f prime of x equal to 0? That's the question that we're answering here. And so we're going to say, well, 3x squared minus 4x, when does that equal 0? Okay. Well,
Can we remove
let's factor this out.
x?
This is x times 3 minus 4x equals 0. And so when x is equal to 0, I get a horizontal tangent. Okay. And when x is equal to, what is this, 3/4? Or sorry, 4, 3. Should be 3.
Got the wrong. I think you factored wrong because it's 3x squared, and you put it on the x on 4x when you factored out the x.
X squared. Oh, yeah. Thank you. So it's the 3x minus the 4. Yeah, there you go. So this is going to be 4/3. Okay, so it says find the points on the graph where this thing is this horizontal tangent. Okay, so I got to plug this into the original function. Well, what's f of 0? F of 0 is going to be 0 minus 0, which is 0. So I know that the point 0, 0 has a horizontal tangent. Okay, so I don't know what this thing looks like, but I'm taking a gander that it's something like this or something. I don't know. Okay. So actually, let's make it more accurate to what we're working with. Come on. Erase for me, baby. There we go. Okay, so it would look more like this. Yeah. Look like this. There we go. Okay, it's saying that at 0, 0, it has a horizontal tangent. Well, that makes sense. At 0, 0, it would be horizontal tangent, okay, right there. And then at 4/3, it also has a horizontal tangent. Okay, so, and then we would just plug in 4/3 into x, and we would evaluate that, and it would come out with negative 32/27, I believe. Yeah, negative 32/27. Okay, if you plug that in, and you did all the fraction work, you would get 64/27 minus 2 times something over 16, or sorry, this would be 16/9, so this would be 32/9, and then you would just have to reconcile the fractions, and you would get 32/27. Okay, so this would be, the second point would be at 4/3 and negative 32/27 for 22. Okay, I think we had 40 and 41 as well. Okay. Okay, 40 says differentiate this guy. Okay, so I'll do 40 down here. Okay, actually let's do 41 first. Okay, let's get 41 out of the way. It's a little bit easier. This I can break up into 1 plus x times 1 plus, 1 minus x plus x squared all over 1 plus x. So I can do that. I can break it up. It's factorable. So this is called the sum of two cubes. Okay, it's like 1 cubed plus x cubed, and the pattern there is a plus b. If you have a squared plus b squared, okay, or sorry, a cubed plus b cubed, and this is a plus b, and then a squared minus ab plus b squared. That's the formula for that. And we use an acronym called SOAP, S-O-A-P. Okay, so this has the same sign. This always has the opposite sign, and this thing is always positive. Okay, and that goes along with the plus sign there. It's a plus b, and then it's the opposite sign, which is a minus sign, and then it's always positive. Okay, but it always follows this pattern. Okay. What that allows me to do is cancel these out, and then I can plug the -1 in here. Okay, and I just end up with 3. So if I plug -1 in there and -1 in there, okay, I get 2 plus 3, 2 plus 1, which is 3, so the limit is 3. So that's 41. Okay, let's differentiate 40. Okay, so 40, we have y equals, okay, fractions inside of fractions. That's kind of interesting. Okay, so yeah, I'm going to use the chain rule on this. Think about how I want to approach this one. Well, let's just write it out anyway. 2 minus 3x to the 2/3 times 5 plus x to the 1/2, all to the 1/2 power, right? Okay, so what's nice is that these things are being multiplied. Okay, so what I can do is when I do a power, when I do a times b to the nth power, that's the same as a. That's the same as a to the nth times b to the nth. Okay, that's a property of exponents. So what I can do here is I can say, well, this is the same as 2 minus 3x to the 2/3 raised to the 1/2 times 5 plus x to the 1/2 raised to the 1/2.
So now both of their exponents would become, oh, never mind. One of them would become 1, and the other would become 1 over.
Now one would become 1/3, right? Because you're going to multiply them together. Power to a power is multiplication. So we would get 2 minus 3x. Okay, and keep in mind, I haven't done any calculus yet. I'm just doing algebra. Okay, and simplifying this first. Okay, so this is 1/3, and this is times 5 plus x, okay, to the 1/4. Okay, so now this looks, this screams to me product rule. Okay, this screams out, use the product rule on this one. So that's what I'm going to do. Okay. So this is going to give me 1/3 times 2 minus 3x. I don't know why it's freaking out like that. Okay. 1/3, 2 minus 3x to the negative 2/3. I've got to subtract 1/3 minus 1. So that's negative 2/3 times the inside. Okay, that's times the inside. Remember the product rule is f prime of x, g of x, plus g prime of x, f of x. Okay, so times the inside, but this is a chain rule. They're both going to be chain rules. Okay, times negative 3. Okay, so that's kind of nice because the 3's here will cancel out. Okay, times the second, which is 5 plus x to the 1/4, plus the derivative of the second, that's 1/4, times 5 plus x to the negative 3/4, times 1. Remember that one, where's the 1 come from? It comes from the chain rule. Okay, and then times the first, which is 2 minus 3x to the 1/3. Okay. Nice. Very nice. Okay. Okay, looks good. Okay, let's see what we can do to clean this thing up. This is negative 5 plus x to the 1/4 over 2 minus 3x to the 2/3. Okay, plus 2 minus 3x okay, 2 minus 3x to the 1/3 over 4 times 5 plus x to the 3/4. Well, I'm gonna get a common denominator here, real quick. Okay. I'm gonna get a common denominator. I'm gonna multiply both top and bottom here by 2 minus 3x to the 2/3 over 2 minus 3x to the 2/3. Boy, that's annoying. Okay, and over here, I'm going to multiply both top and bottom by 4 times 5 plus x to the 3/4, and 4 times 5 plus x to the 3/4. Okay, so I'm gonna do that. Okay, what does that allow me to do? Well, it allows me to get a common denominator here of 4 times 5 plus x to the 3/4 times 2 minus 3x to the 2/3. I'm gonna have to reload this thing in a minute. Okay, and then notice that the 3/4 and the 1/4, what do they add up to? Well, they add up to 1, right? So this just becomes -4 times 5 plus x. Plus, that's why I did this. Plus, well, what does this add up to? 1/3 and 2/3. That just adds up to 1 as well. So this is plus 2 minus 3x. That's kind of cool. Okay, so if I distribute this, I get -4x and -3x. That's -7x. And if I take -20 and I add it to 2, that's -18. And I get 4 times 5 plus x to the 3/4 times 2 minus 3x to the 2/3. And that's the answer. I'm going to stop my sharing for a second and then try to share it again. I don't know why it's freaking out like that. Okay. That's how you do that one. Woo. That was tough. Okay, what else we got here? We got 37 and 38. 35. Oh, we did 35. 37, 38. Yeah, okay, we can do 37 and 38. Okay. So let's go back. Everybody got this one? Good. Okay. So 37 and 38. Ooh, oh, composition of functions. Derivative of composition of functions. Okay, cool. Okay, so let's do 37 here. 37 is f of g of x. So okay, f of g of x. Well, if I take the derivative of that, that's just the chain rule. That's the chain rule. That's kind of cool. Okay, so let's do f of g of x. Well, what is f of g of x? Well, we're going to plug in f g of x into x and f of x. Okay. So this is going to be, okay, 2 times x plus 5 squared, excuse me, minus x plus 5. Okay. So now I want to take the derivative of this. Well, it's a chain rule. Okay. So let's do, this is going to be 2 times x plus 5, or 2 times 2x plus 5. That's what it is. Okay, 2 times 2 times x plus 5 to the first power times the derivative of x plus 5. Well, the derivative of x plus 5 is just 1. Okay, minus the derivative of x, which is 1, plus 5, which is 0. So this is minus 1. Okay, so this is 4 times x plus 5. All those ones cancel out, minus 1. Okay, and so we're left with 4x plus 20 minus 1, which is 4x minus 19. Okay, so this is 4x minus 19. That's f prime of g of x. Oh, sorry, it's plus 19. Plus 19, thank you. Okay, plus 19. Okay, so that was 37. Okay, let's try 38 here. Okay, we want it to be backwards, g of f of x. Okay, so we're gonna plug this guy now in here. Okay, so we want g of f of x, which is gonna be plugging in f of x into g. So that's just gonna be 2x squared minus x plus 5. Take the derivative of this one, well, this is just 4x minus 1. Okay, and so that's it. Yeah, 4x minus 1. Okay. So that's that derivative. Okay, others? Do you want to see done here? On chapter 1. Yes, okay. Find the simplified difference quotient. Okay, so yeah. So the difference quotient is f of x plus h minus f of x all over h. Okay. So let's see what we got here. So this is going to be 5 times x plus h squared minus 8 times x plus h minus f of x, which is just my original function, x squared minus 8x. Okay, and then it's all over h. Okay. So I'm going to multiply this x plus h squared out. That's going to be, well, x plus h squared equals x squared plus 2xh plus h squared. So keep that in mind. And I'm just going to distribute the 5 on that. This is going to be 5x squared plus 10xh plus 5h squared minus 8x minus 8h minus 5x squared plus 8x. Okay, so that guy's gone, and that guy's gone. Okay, all over h, right? All over h. Okay, so this thing, if I factor out an h on the top, I get h times 10x minus 8 plus 5h all over h on the bottom, boom, boom, and that's my simplified difference quotient right there. That'll be 20 right there. This would be 10x minus h, or minus 8 plus 5h. Okay. Okay, any others? $29. Okay. 39. Okay. Okay, 29 is product rule, right? Okay, so derivative of the first, that's 6 over 2 radical 2, or sorry, 2 radical x, radical x, plus is 2, that's 0, right? So derivative of the first times the second, plus the derivative of the second times the first. Okay, so and the only thing I'm going to do here is just get rid of this 2 and this 6. I'm going to write this as a 3. And that's about it. That's 29. I don't want to clean that up. I really can't clean that up too much. And I wouldn't want to. It just would become a nightmare. So just kind of leave it like that. Okay. Make sure you know what the derivative of radical x is. That's one of those I wanted you to memorize. Okay, number 39. Okay, marble rolls along a level table. Okay, rolls along a level table and then down an inclined plane. Okay, let S of t represent the marble's distance after starting the roll. Which graph best represents S? So the marble's distance. Okay. Okay, the total distance. Which graph is gonna? Okay, so it seems like if I roll a marble, okay, the distance would increase at a constant rate, because this seems like it would be going along at a kind of a constant rate. There might be some friction involved, but for the most part, it's going to speed along at a certain rate, and it's not going to slow down much. Okay, so as the time increases, the distance will increase the same amount. It'd be like going 60 miles an hour, right? The time is 1 hour, the miles is 60. Okay, constant rate. I'm going to say that it's a constant rate here, which means that it's going to be linear. So I can get rid of B here, because for the first part, it's going to be a line. Okay, and then what's going to happen, okay, here, as it goes down, well, that marble is going to start traveling faster and faster and faster. It's going to go because of the force of gravity. It's going to travel faster and faster and faster until it hits the bottom. Where'd my graph go? Come back. Okay, so then it travels down an inclined plane. So this is where you're speeding up. Your speed increases. Okay, so it's speeding up. Well, it's not. It keeps speeding up faster and faster. So it's gonna be more of a exponential curve, because it's got to be faster, more distance in this second than in this second. More distance would have been covered in the later seconds than the earlier seconds. So in order to, it doesn't just immediately speed up and stay at the same speed. It goes up. So the answer is A here. Okay, it continues to increase. The speed increases until it hits the bottom. So it's not going to continue to go at the same rate. So D is out. And it's not going to just go up in rate. Okay, C would only happen if if I kept it here and then I increased the speed, but I didn't increase the incline. You know, something here and it like those, if you ever played with Hot Wheels, I don't know if you played with Hot Wheels as a kid, but if you had a marble and then you had this little thing that's a kind of a bumper here, okay, on a motor, okay, and then it hit this thing and it sped out faster. He's getting mine. And then it sped out faster. Okay, that's how you would get C. But the only one that makes sense is A. Again, let me stop my sharing because I don't know why this thing's freaking out again. Maybe it's the internet connection, who knows? My mousey mouse. Okay, others? Any others you want to see done? That's funny, thank you. Yeah, exactly. R6, okay, sounds good, R6. Okay, find the average rate of change in R6, okay. Going up here. Okay, average rate of change. Okay, well, for every 1, I go up what? Or for every 2, right, I go up 1. So it's not to scale, which is kind of like throws you off. But for every 2 items I go over, I go up 1 item. And so the rate of change is just the slope of this line, which is 1 over 2. Okay. Inches per month. So it's a little deceptive. Okay, it's a little deceptive because those blocks are really 1 by 0.5 blocks. Okay, 33. Okay, so we have 32 and 33. Okay, so 32, again, chain rule. So this guy is just a chain rule. Y prime is equal to -4 times 6x squared minus 10x plus 1 to the -5th power times 12x minus 10. Okay. And I could pull a 2 out of that if I really wanted to. If I wanted to. But maybe I don't want to. Okay. Where is this? 32? Okay, yeah. Okay, and you can put this on the bottom if you really wanted to as well. Okay, 33. So we have x times x to the 6th to the 1/2 minus 2. Okay, so I'm going to clean this up. Okay. Oh, you know what? There's a typo here on 33. This should be like this. Okay, so yeah, sorry about that. There's a typo on 33. So I'll make a note to myself to change that so it doesn't happen again. So 33, it should be extended. 33. Okay, so this becomes, you're like, probably like, I did the problem, but it didn't match up with the solution. Okay, so this is going to be x times x to the 6th minus 2 to the 1/2 power. So this is a product rule. Okay, so the derivative of the first times the second, well, that's just the second. That's just f prime of x, okay, is equal to, okay, x to the 6th minus 2 to the 1/2, because it's just 1 here. 1 times, derivative of the first is 1, okay, plus derivative of the second times the first. So I could put the first in front, and then derivative of the second. Okay, just put that x in front. The derivative of the second, that's going to be 1/2 times x to the 6th minus 2 to the negative 1/2 times the derivative of the inside. This is a chain rule. Derivative of the inside is going to be 6x to the 5th. Okay. Okay, and so this will clean up, and this becomes x to the 6th minus 2 to the 1/2. Maybe I'll rewrite this in terms of square roots, because they gave it to me in square roots, so maybe I should just leave it in square roots. Okay, so this is equal to the square root of x to the 6th minus 2, plus, this is going to be 6x to the 5th divided by 2, which is 3, and then x to the 5th times the extra x here is going to be x to the 3x to the 6th, all over the square root of x minus 2. Sorry, x to the 6th minus 2. And so that's the answer to that one. Okay, that thing goes downstairs because it's a negative exponent. Okay, 25. I'll do 25 real quick here. Okay, this is just negative 8x to the negative 3rd. So that's positive 24, x to the negative 4th. So y prime is equal to 24 over x to the 4th. Okay, and then uh, 21 on R. I already did 21 on chapter R. I believe, is that right? No? No. That's chapter 1. Sorry. I did. Oh, okay. Graph this guy. Okay. So, yeah, let's graph this guy. This is a parabola, but it's only valid for when x is greater than or equal to negative 2. So let's look at what happens at negative 2. At negative, we're at negative 3 for the y-intercept for this guy. It's an upside down parabola, which means that it looks like this. Okay. Okay. And that's for if it's greater than or equal to 2, negative 2. If it's less than negative 2, then we just have a line, x equals negative 1. So we have the line negative x equals -1, okay, which looks like this. Okay, actually, looks like, oops, goes through here. Okay, but if this is only valid, that's only valid if it's going this direction. So, I don't know, so something like that. Okay, you can get rid of this if you wanted to. Okay, and if you wanted to graph that parabola, you could easily plot some points to graph that parabola. You know, you could find out, well, what's it at -1? You know, what's it at -2? What's it at 0? What is it doing at 1, at 2, and therefore, you know, and you'll be like, oh, at 1 it's at -4. So you could easily plot some points. Okay. Okay, and so forth and so on. Okay. Okay, others? Number 10 on chapter 1, okay. Number 10 on chapter 1. Okay, find f prime of 2. Okay, so let's look at the graph here. The derivative, we want the derivative at 2. Okay, what's the derivative at 2? Well, what's the slope at 2? What's the slope of the line at 2? Well, looks to me like it's 0. Okay, the slope of that line, because that's what derivative is. It's the slope of the line, right? Slope of the tangent line. And here the tangent line is the line. So the derivative is 0. Okay, and keep in mind that you do have the answers to all these, hopefully. Okay, you have the answers to chapter R review and the answers to chapter 1 review. So this is, you know, I'm just supplementing and saying, hey, I didn't know how to get the right answer. How did you get the right answer? But the answers are all there for you. Okay. Okay, keep in mind that I do have office hours. When do I have office hours? 5 o'clock on Thursday. I will also be in the Success Center from 9 to 1 on Thursday. Okay, so if you find yourself studying